Now, our previous slide introduced us to the idea of planetary accretion, the small things collapsing to form bigger things, running into each other, make even bigger things, and eventually they build up planets. And this was very good at explaining several aspects of the solar system. Why do we have inner rocky planets and outer gas giant planets? And really far out, we have Pluto and several other things like Pluto that are just icy things. And so this really made sense. Okay, there were a couple of things that did not fully explain. One of those was the asteroid belt. Okay. And it did not really fully explain Jupiter and Saturn. Okay. Uranus and Neptune explained very well because we have evidence that the interior of Jupiter, of Uranus and Neptune is in fact something that's probably rocky, icy, and watery. It pulled in a lot of this extra water, H2O, and then it has enough mass because it's so big, it can pull in hydrogen and helium, and it can accrete these very huge worlds here. Okay. Jupiter and Saturn, though, are a little bit problematic because they've got too much hydrogen and helium. In fact, they're almost all hydrogen and helium, especially Jupiter. Jupiter is mostly hydrogen and helium with only a little bit of other stuff. And then Saturn seems to be about the same. In fact, it seems to be that Jupiter in particular, and maybe Saturn as well, the amount of other stuff is pretty much what you would expect from about 4.5 billion years of asteroids and comets running into it. And so maybe a little bit more stuff than that in Saturn, but we're not real sure. But those two worlds seem to actually be a little bit different. So what does that mean? Well, it means there might be more than one way of actually building a planet. The accretion model that we were talking about here, the accretion here, we got two types of accretion. We have total accretion and core accretion. Total accretion would be like Mercury, Venus, Earth, Mars, in which all the stuff just runs together and makes those worlds. Core accretion would be like the gas giants of Neptune and Uranus, where the core accretes, all this stuff comes together to make this really big planet that has enough gravity to pull in all the hydrogen and helium, and that makes an even bigger planet. Okay, so the core accretes and then the gravity pulls it in. It's entirely possible, though, that Jupiter and possibly Saturn form in a different process that we call the disk instability model. In the disk instability model, sometimes called the gas collapse model, what happens is in that proplet, that just random fluctuations, shock waves, turbulence, a variety of different things can cause one part of it to end up being thicker and denser than the rest. If that happens, then gravity pulls that section together all by itself. We don't need to get an accretion of a core. It just directly pulls itself together out of the hydrogen and helium and other stuff that's in there. Remember, that's the main part, that's the main composition of the sun. So this disk, the proplet, was originally part of the accretion disk of the sun. So that means that a planet that forms in this process is going to have almost the same composition of the sun, just like Jupiter, and to a lesser degree Saturn. And so that means that this would pull in even more dust and some gas and make it even bigger. Okay, so over time, you know, over billions of years, then what will happen is meteorites and planetesimals run into it, and they'll make a solid core. But the bulk of it is still the hydrogen and helium. Okay, and so that would explain Jupiter and then Saturn. Now, Saturn we're not sure about. They still argue. Sometimes they think Saturn is formed by the direct gas collapse, and sometimes they think Saturn is formed by core accretion, and sometimes they think Saturn is like a mixture of the two. Okay, so So what would happen is the accretion model, that explains most of the planets in the solar system. Okay, Mercury, Venus, Earth, Mars, Neptune, and Uranus. The gas collapse model definitely explains Jupiter and probably Saturn. Well, this raises a huge, interesting question. We had this huge debate years ago about what makes up a planet. Remember, a planet is a wanderer. Well, that's the ancient definition. And then they started discovering all these other things out there, and they said, wait, we can't have everything on the list of the planets. That's too many. So we need to have a definition of planet as something that is somehow distinct or different from all these asteroids and comets and everything else that fly around the solar system. And so that's when they came up with the definition of planet. In that definition of planet, they admitted that some of these things are kind of like planets, but they're just not quite big enough to be considered planets. And so they came up with the idea of dwarf planet as a way of explaining that. Okay, and that seemed to make people happy. But the problem is that we have two distinct categories of objects here. In what we call planets, some of them form by accreting, and some of them directly form out of the proplet as just clumping up. Okay. Not accreting, just clumping up. Okay. And so that means that these are distinctly different kinds of objects. So should objects that form and build up from small to big as accretion, or stuff that just suddenly clumps up out of the proplet, should those two type of objects be really considered the same kind of object? Okay, so this is really a deeper question as to whether Jupiter and Saturn should be on the list of planets. Originally the question was, should Pluto be on the list? Should Pluto and then Eris be on the list? Okay, should Pluto, Eris, Haumea, Makemake, and so forth, should they be on the list? Okay, that was the question everybody was asking. Nobody was talking about dropping Jupiter and Saturn off the list. But the reality is Jupiter and Saturn actually formed in an entirely different process probably than did the other planets. And so that means that they are quite possibly different kinds of objects than the others. Which means, well, maybe they should not all be on the same list that we call planet. So maybe we should actually divide this thing up into something else. And so, but that's an argument here that would be an interesting debate. But I don't think anyone wants to take that up, because that just really flip out the public if we drop Jupiter and Saturn from the list. I mean, it was tough enough dropping Pluto from the list. So there we have it. The formation of the solar system, things coming together, making the planets. Okay, probably two different ways of making planets.